Hello everyone. Today we will be working through some bond valuation review questions. So keep in mind that a bond is a fixed income security, meaning that as a bond holder you will receive fixed interest payments called coupons, and then a principal amount called the face value when the bond matures. There are equations that you can use to value these bonds, and when I say value these bonds, it's just solving for the price of these bonds. But I will be doing these problems using the financial calculator. So here in number one, we have bonds that have 10 years remaining until maturity. The interest is paid annually. The bonds have a $1,000 par value. Coupon rate is 8%. Yield to maturity of 9%. What is the current market price of these bonds? So I'll start this one off just by drawing a timeline to showcase what we're actually doing here. So as I mentioned, bonds are fixed income securities. So here we are going to be receiving a fixed income amount of 8%, and that 8% fixed interest payment is going to be paid annually. So in my timeline here, today is time period 0. I will have 10 periods on my timeline. Since these cash flows are paid annually, I will receive my set interest payment each year until the bond matures. And on that date when the bond matures, I receive my final interest payment plus the face value of this bond, in which they say the bond has a face value or a par value of $1,000. So what we are trying to do is figure out what is the present value of all of these expected future cash flows. And when I'm solving for the present value of these expected future cash flows, I'm going to discount them back at the going rate out in the market for bonds of similar risk, or otherwise referred to as the yield to maturity. So here in my financial calculator, I'm using the time value of money row, in which I have 5 inputs. I always group these 3 inputs together because the payment, the N, and the IY are input in on a per period basis, and the present value and the future value are lump sum amounts. So here the payment, the N, and the IY are all going to be input in annually, since the cash flows or the interest payments, the coupons, are received annually. So these are all going to be input in on an annual basis. Let's just go through the different items here and assign them to the different inputs on our financial calculator. First thing we have is 10 years remaining until maturity. That is your N. That is the number of periods until the bond matures. Next piece of information we have is the $1,000 par value, which is also thought of as which is also referred to as the face value. That is the amount that we receive when the bond matures, and that is our future value. So here what we have done is we have input that future value from our timeline. That is the cash flow I receive at the end of the 10 years. The next thing we have is our coupon rate. So here it is saying that the coupon rate is 8%. 8%, this coupon is the interest that you receive as the bondholder, and it is a percentage of the par value. So this is going to be this regular interest payment that I receive each period while the bond is outstanding, and it is going to be 8% of the $1,000 par value, and this is going to go in as my payment. The only time you can ever insert a value for your payment function is if that cash flow occurs every single period for whatever you put in there for your N. So as you can see from my timeline, I receive the same cash flow each period for the 10 years that this bond is still outstanding. So let's calculate what this payment amount is. So we are going to take 8%, the coupon amount, multiply it by the par value, and I get an $80 annual coupon, or $80 annual interest that I would receive as this bondholder. The IY is our discount rate. We are going to be discounting these cash flows back at whatever the yield to maturity is. Once again, this is going to be input in as an annual basis. Your yield to maturity is always quoted on annual terms. So our yield to maturity is 9%, and that is going to be our discount rate. We are solving for the present value. Once again, the present value is just going to be the price of this bond. So when I input this into my financial calculator and solve for the present value, I receive a value of $935.82. It does come out as a negative value because the calculator must have one of these cash flows as a negative value, but this is actually a positive amount. So the price of this security would be $935.82. So based on its level of risk, which is measured by the yield to maturity, our discount rate, and the different features of this bond, an 8% coupon and 10 years until it matures, the current fair value or the current price would be $935.82. You can think of this negative sign as being that's what you would be paying a cash outflow in order to receive cash inflows of $80 each year for the next 10 years and a lump sum amount of $1,000 at the end of the 10-year period. And those cash flows are positive because I would be receiving those cash flows. So let's move on to number 2. So calculate the yield to maturity on the following bond. So if I'm calculating the yield to maturity, I am given the price and I'm solving for the discount rate that makes the present value of the future cash flows, my coupons and my face value amount, equal to what the current price is. So here, once again, we are using the time value of money row, and as I mentioned, we are solving for this IY, our discount rate. Once again, grouping all those together because these payment and IY should all be input in on a per period basis. As you can see here, the coupons are paid semi-annually, so all of these inputs, payment and an IY, will be input in on a semi-annual basis, and we are solving for the IY. Now, before we get started, keep in mind that with the IY calculation, since all of these are going to be input in semi-annually, it's going to give me my output semi-annually as well. And yield to maturity is always quoted on an annual basis, so I will need to make an adjustment once I do solve for this yield to maturity. So the first thing that we have is a 9% coupon bond. So 9% coupon bond would be my payment. We are going to take 9% of our face value, which is $1,000. And on an annual basis, they are going to pay $90. However, this coupon is paid semi-annually, so they break down this annual coupon amount into 2 separate installments. So I would have $90 divided by 2, and I would receive $45 every 6 months as a bond, as a holder of this bond. Your N, well, let's just go in order of what's provided here in the details. We have a $1,000 face value. That is the future value amount, the amount that I will receive at maturity. I have 15 years until maturity. So N is your number of periods until the bond matures, 15 years, but once again, needs to be input in on a semi-annual basis. So how many semi-annual periods are there per year? Just 2. So a total of 30 periods remain in this bond. And then the present value is what the bond is currently selling for. In this case, the bond is currently selling for $985. If I were to type in my inputs like this and try to solve for the IY, I'm going to get an error 5. And the reason is because I do not have one of my cash flows as being a negative. So once again, if I were going to buy this bond, I would be paying $985. So I'm going to represent that as a negative value for my present value. And I will keep my payment and my future value as positive value since I would be receiving those cash flows. So then when I solve for the IY here, I get a value of 4.59. But once again, this is the semi-annual yield, and your yield is always listed as an annual basis. So since that is a semi-annual yield, how do I adjust it to an annual amount? I will multiply it by 2, and my annual yield to maturity then is 9.19%. So that is my required return based on the given price and the different features of this bond. Looking at part B, once again, same setup except different features of the bond. And once again, we are solving for the yield to maturity. So I have present value, future value, payment N, and IY. It's always wise to start this off by identifying how these should be input. These are going to be paid quarterly. So all of these inputs need to be input in on a quarterly basis. Now, before we even start this problem, and I didn't do this on the last one, you can always tell whether or not this yield to maturity is going to be greater or less than your coupon rate based on the current price. So if I go back to part A, I see that this bond is selling for $985. So this is selling for less than your par value amount. This occurs when the coupon rate is less than the yield to maturity. So if bonds of similar risk out in the market are offering a higher, are providing a higher return than what this bond is providing in regard to its coupon rate, the bond will always sell at a discount. Okay, so once again here looking at part B, we can see that this bond is selling for $915, so this is selling for a discount. So I should expect to receive an answer for my yield to maturity that is greater than whatever the coupon rate is for this bond, 8%. And we can verify that here on the upcoming calculations. So present value is the current price. We have a current price of $915. Once again, I'm going to list that as a negative value since I would be paying that if I were buying this particular security. Future value is the face value amount that you receive at maturity. It's going to be that $1,000. So my future value is $1,000. My payment is the per period coupon amount. So once again, it is 8%. Our coupon percent is 8% of par value, which is $1,000, so $80 per year, but once again paid quarterly, so I need to adjust this and divide by 4. I would receive $20 in interest every quarter from this bond. N is the total number of periods remaining, or the total number of coupons that you can expect to receive. You can think of it that way. There are 10 years remaining, but 4 payments per year for a total of 40 periods remaining. And once again, we are solving for the IY. When I initially solve for the IY, I get a value of 2.3289%. But once again, since all of these were inputting quarterly, that is a quarterly interest rate. So I'll need to multiply that by 4 to get an annual rate of 9.32%. Now, once again, before we even started, we saw that this bond was selling at a discount, and these bonds sell at a discount when the coupon rate is less than the yield to maturity. Once again, we saw and verified that when we had a coupon rate of 8% and the bond was selling at a discount, our yield did end up being greater than that coupon rate. So it did verify our thinkings that we were going to have a yield to maturity that was greater than our coupon rate because the bond was selling at a discount, less than par value, less than the $1,000. Let's test that again here in Part C. So here we have another scenario, but now the bond is selling for $1,065. So this is what is called a premium bond. Premium bonds occur when the coupon rate is greater than the going rate out in the market for bonds of similar risk. So this bond is offering a higher interest rate than other similar bonds out in the market of similar risk, which is also referred to as our yield to maturity. So we should expect to get a yield to maturity answer in this one that is less than our 11% coupon rate that is provided for this particular bond. So we have present value and future value. We have payment, we have N, and we have IY. Once again, it's wise to identify how these inputs should be input. Here it's all paid annually, so these values are going to be input in on an annual basis. So let's just work through and plug in our different inputs. We have an 11% coupon. That is our annual payment here. So 11% of $1,000 gives me an annual payment of $110. It is paid annually, so we just leave it at $110. Next up, we have the $1,000 face value amount. That is the future value that we receive when the bond matures. So we have that $1,000 there. We have 6 years until maturity, so that is our N. So our N is 6. We are solving for the IY, and this current price is our present value. So $1,065. Again, if I type it in as is, as it's posted here, I will get an error on my calculator. One of these needs to be a negative. We will make the present value a negative to showcase that's what I would pay in order to receive all of these future cash flows. So now when I solve for the IY here, we do expect it to be... since it is a premium bond selling for greater than $1,000, we do expect this yield to maturity to be less than 11%. When I solve for the IY here, I do get a value of 9.53%, which is indeed less than the 11%, just like we started, or just like we identified before we started the problem as to what type of answer we should receive here. So that is calculating for the yield to maturity. Once again, the yield to maturity is essentially the going rate out in the market for bonds of similar risk. It can also be thought of, if I pay this amount for this bond and receive all of these future cash flows, this is the yield that I would earn at until maturity if I were to purchase this bond. So you can take it as a literal term as yield to maturity. What return do I receive if I hold on to it until maturity and receive all the promised cash flows? That's what we just got done calculating. So looking at number 3 here, we have a $1,000 par value bond, 5 years left to maturity, interest rate semi-annually with a 5% coupon rate, price to have a 4% yield to maturity. If interest rates surprisingly increase by 5%, how much will the bond's price change? So we're going to have 2 calculations here, one what the current price is, and then one with what the future price will be if interest rates do actually increase by 5%. Before we even get started here, we know that we are solving for the price. So we are solving for the present value. And once again, we can get an idea as to whether or not this bond's price should be greater or less than $1,000 by comparing the coupon rate and the going rate out in the market for bonds of similar risk. So since this bond is offering a 5% return and bonds of similar risk out in the market are offering a 4% return, this bond is going to be selling at a premium since it's offering a higher interest rate than other bonds of similar risk. So we should get a price or a present value here that is greater than the par value of $1,000. So let's just go ahead and plug in our inputs. We have a $1,000 par value bond. That is the future value that I would receive at maturity. My payment is the coupon amount that I would receive per period. It is a 5% coupon, so 5% of $1,000 or $50 per year. However, it is paid semi-annually, so all of these inputs should be input in on a semi-annual basis. So $50 per year broken down to 2 payments gives me $25 every 6 months. My N represents the total number of periods that remain. 5 years on this bond, 2 periods per year for a total of 10 periods. And my IY is that yield to maturity input in on a semi-annual basis, so 4% for the year divided by 2 gives me a 2% semi-annual yield. When I solve for the present value here, I get a value of $1,044.91. Once again, it does come out as a negative, but that is an actual positive value, just represents that's what I would be paying if I were buying this bond based on these different features. Now, if interest rates suddenly increase by 0.5%, we have to remember that there is an inverse relationship between interest rates and the price of bonds. So what does this mean? If interest rates go up, the prices of bonds go down, and then vice versa. If interest rates go down, the pricing of bonds go up. And you can see the price I'm notating here by present value because that's what the price is. The price is the present value of the future cash flows. So let's see what happens here. We do expect our price to go down since interest rates are increasing by 0.5%. On our inputs, everything is really the same except for that IY, our yield to maturity. So we're still solving for the present value. The future value is still the face value amount of $1,000. All of these inputs are once again still input in on a semi-annual basis. We're still receiving $25 every 6 months. We still have 10 total periods remaining on this security. But now the AP or the yield to maturity is 4.5 since it has increased from 4% and increased by 5% or 0.5%. So now my yield to maturity is 4.5. Again, I need to input that in as semi-annually. So my semi-annual yield is 2.25%. When I solve for the present value here, I get a price of $1,022.17. Again, it comes out as a negative, not an actual negative value. But just like we thought, when interest rates out in the market went down, the price of my bond, sorry, I have that backwards. When interest rates out in the market went up, the price of my bond did indeed go down. And so what they're asking for is how much will the bond's price change. They're looking for a dollar amount here. So the price change would be the ending value minus the beginning value for a decrease of $22.74. So just looking at the relationship between bond prices, which is the present value of the future cash flows, and how changes in that interest rate have an inverse relationship on the values of these outstanding fixed income securities. Moving on to number 4. Similar setup, $3,000 face value bond, or similar setup in terms of we have a bond, interest rates out in the market all of a sudden change from 7.2% up to 8.6% due to an increase in the riskiness of the securities. One item that goes into the riskiness of these fixed income securities is the credit rating that these issuances have. In this case, the credit rating went from BBB down to BB, so there was an increase in default risk, a decrease in their overall credit score. And so my required return, my yield to maturity, has now increased from 7.2% to 8.6%. And once again, they want to know what will be the change in the bond's price in dollars and also percentage terms. Slight differences, though, on this problem in regard to the actual inputs. So once again, we are still solving for a change in price. So we're solving for the present value of these future cash flows. My payment, my N, and my IY all need to be input in semi-annually. The main difference here is that now we have a $3,000 face value bond. So at maturity, instead of receiving $1,000, I'm going to receive $3,000. So that is my future value. My future value is the principal amount or the face value, the par value. It all means the same thing. I will receive $3,000 at maturity. Again, though, with the payment here, that's also going to be slightly different because we have a 6.5% coupon. This is 6.5%. Previously, in all of our calculations, we've multiplied this value by 1,000, but it is 6.5% of face value. So I'm going to take 6.5% and multiply it by the face value of $3,000, and I would receive $195 per year in interest. However, it is paid semi-annually, so I need to take this value and divide it by 2, and every 6 months I would receive $97.50. Our N is our total number of periods that remain. As you can see, we have 10 years until maturity, so it would be 10 years, 2 periods per year for a total of 20 years. And the IY then is your yield to maturity, your going rate out in the market for bonds of similar risk. Here it is 7.2 initially when they had the rating of a triple B. And so 7.2 on an annual basis. I divide this by 2 since it needs to be input in semi-annually. And so my semi-annual discount rate is going to be 3.6%. I solve for the present value. I get a present value. Well, before we even start, quick review. 6.5% coupon relative to a 7.2% going rate out in the market from bonds of similar risk. You should realize here that since the coupon rate is less than the going rate out in the market for bonds of similar risk, that this bond is going to sell at a discount. So a discount of face value, in this case a discount of $3,000. So the bond should sell for less than $3,000. When I do my calculations, I do indeed see that the price is $2,852.11. I'll stop mentioning here the negative sign. Once again, we do realize that it will come out as a negative, but that is a positive value. So let's take a look now what happens to the price when the credit rating is downgraded and the yield actually increases to 8.6%. Present value, future value, payment, N and IY. Once again, these all need to be input in on a semi-annual basis. Nothing in the details of this bond has changed, so we still have a $3,000 future value or principal amount that I receive at maturity. Still solving for the present value. The semi-annual interest is still $97.50. My N is still 20 periods that remain, but now the discount rate, my yield to maturity, is 8.6% for the year. Divided by 2 gives me a semi-annual yield of 4.3%. When I solve for the present value here, I get a price. Once again, if interest rates out in the market go up, the price of my bond should go down, so it should be less than $2,852. When I solve for this, I get a value of $2,583.06, just like we thought, less than the actual than the previous calculations when we used the discount rate of 7.2%. So now they want to know what will be the change in the bond's price in dollars and in percentage terms. So let's take our ending value of $2,583.06, subtract our beginning value of $2,852.11. We can see that we have a decrease of $269.05. So this is a monetary amount, a dollar amount. It has decreased $269.05. Now let's do it in terms of percentage terms. In percentage terms, to calculate a percent return, you take your ending value minus your beginning value divided by your beginning value. We've already done ending minus beginning, so we have a negative 269.05 in our numerator. Our denominator is our beginning value of 2,852.11, and we get a return of negative 0.0943 or negative 9.43%. So it decreased by $269.05, which is a 9.43% decrease over this period. So a lot of repetition here with these practice problems, a lot of variation in the individual inputs, but it's really the same concept over and over when you value bonds. The key is understanding what the sides of the cash flows are, so really what the coupon amount is going to be, and the par value amount at maturity, and also the timing of the cash flows. So when do those cash flows occur, for how long do they occur, and then you discount them back at the relevant interest rate, which is that yield to maturity, the going rate out in the market for bonds of similar risk. Continuing on here, we have just been offered a bond for $863.73. That is our present value. We have a coupon rate of 8% payable annually. Now, before we even moved on to the next section of details here, we see that we have an 8% coupon bond. The bond is selling for a discount less than par value. So we know that the going rate out in the market for bonds of similar risk is greater than our coupon rate. Indeed, when we get to the next sentence, we see that the yield to maturity on these bonds is now 10%. Now we want to know how many more interest payments received, but the party selling the bond cannot remember. So they want to know how many interest payments remain. So here we are solving for n, our number of periods. So once again, we have present value, we have future value, we have payment, n, and IY. Again, these all need to be input in on a per period basis. In this case, we have 8% payable annually, so these will all be input in on an annual basis. So you can see that these are input in on how frequent the coupons are being paid. Present value is the current price of the bond, $863.73. I will list that as a negative value since that is what I would be paying if I were to purchase this security. Future value is the face value amount or the par value, which is $1,000, so that is my face value amount. My payment is my interest payment per period. It is 8% of par value, or $80 per year, and it is paid annually, so we do not have to make any adjustment on that amount. We are solving for the number of payments that remain. My IY is the discount rate, which in this case is the yield to maturity, which is 10%. So we are solving for the n. When I solve for the n here, I get 12. Whatever my inputs are, it's going to be output in that same unit. So in this case, 12 would be 12 years. The adjustment would be in the event that you are inputting these values semi-annually, then your n is going to be in semi-annual periods, so you would actually have to divide that by 2 to get years if it was semi-annual inputs. But in this case, it is not semi-annual inputs, so our output is in years. 12 interest payments remain based on this information. So once again, we can just continue to apply some of our understanding of bonds and how they sell at discounts and the relationship between coupon rates and yield to maturities, etc., in these different types of review questions. So the next two questions deal with returns. So far we've been talking about a required return, right? Your yield to maturity. This is the return that you require based on the given level of risk of that particular security. You use that yield to maturity in pricing the bond, pricing the fixed income security. You use that as your discount rate on the future cash flows. Taking a look at number 6 here, we see that we bought a bond 5 years ago for $935. The bond is now selling for $980. $75 of coupons or of interest per year, which you reinvested in the bond. So when you solve for the IY, it assumes that you are reinvesting it and reinvesting it in an asset of similar risk, earning the same type of return. So this is just something that we are kind of assuming that we're doing here, is reinvesting the coupons in a similar risk asset. And they now here want us to calculate the realized rate of return. So the realized rate of return is just that, the return that you would actually realize for this particular bond. So this is going to be slightly different on our inputs. And you can visually see this on a timeline. So once again, we can draw a timeline here. So it says that we first bought the bond 5 years ago. So here we have a 5-period timeline. And at the beginning of this period, we paid $935 for this bond, which I will notate as a negative value since that is a cash outflow to buy the bond. Over the next 5 years, now the bond is selling for $980. It paid $75 in interest per year for this 5-year period. They want to know what is the yield that I actually realized if I bought this and received, or I bought at that amount and received all of these future cash flows. So essentially, we're solving for the discount rate that would set the present value of these future cash flows equal to the price that we paid. And here, this is going to be our realized yield on this particular security. So once again, we have these inputs. When you draw the timeline, this initial value is your present value. This is your future value. This is your N. This is your payment, the constant cash flows. And we are solving now for this IY. So let's plug in our inputs. Present value is a negative $935. Future value is the future value lump sum that I would receive if I were selling it today. That's our main difference from our previous problems. If I sold the bond today, I'm not going to receive the face value because the bond is not maturing. I'm going to receive whatever the market rate is, or the market price is. And price is, in this case, it is the $980. My payment is the in this case, annual coupon that I received, so $75 per payment. My N is the number of coupons that I received for this period, which is a 5-year period because I bought the bond 5 years ago, and we are solving for this return. So when I solve for this return here, I get a realized rate of return of 8.83%. So what does this 8.83% mean? I bought the bond for $935 5 years ago. Each year I've received $75 in interest, and then today I received $980 by selling the bond. The return on my $935 investment is 8.83%. Now when I move into question 7 here, using the same information, now I expect to hold the bond for 3 more years and sell it for $980. And the bond is going to continue paying $75 per year over the next 3 years. And now they want to know, what is your expected rate of return? So your expected rate of return is the return that you expect to receive based on what the current price is. With the current price today is $980 from the details from from problem 6. So looking at our inputs here, a couple of these don't change. We still have our payment of $75, our payment of $75. We want to know what the expected rate of return is during this period. So from today for the next 3 years. So what is our N? How many more of these payments will we receive? Our N is 3 in this case. The present value is the price today. From problem 6, the price today is $980. I'm going to list that as a negative value. 3 years from now, the future value that I would receive is the $990. So once again, it's not the par value. I'm selling it for whatever the market price is at that time. And then here we are solving for the IY. When I solve for the IY, I get a value of 7.97%. So the key with problem 6 and 7 relative to what we've been doing previously, we've been solving for the required rate of return, which is your yield to maturity. That is the rate required based on the level of risk of that particular security. We use that to price the bond, the fixed income security. In problem 6, we did a realized return. A realized return is the return that you actually realize for the period that you hold on to the bond. And then your expected return is based on the current price, what return you expect based on the current price and the future cash flows associated with that security. So 3 different types of returns, just dealing with different features. And lastly, we have a bond issue outstanding with a coupon rate of 7%, paid quarterly now. 4 years remaining, bond par value is $1,000. They want to determine the fair value. Hopefully you know by now, fair value is just the price. Market conditions justify a 14% compounded quarterly rate of required rate of return. So once again, we have our inputs. First thing is to remember that all of my per period inputs are going to be input in on a quarterly basis. So those will all be input in quarterly. Another thing that I want to emphasize once again is we have a coupon rate of 7%. Going rate out in the market for bonds of similar risk is 14%. So here we have a coupon that is less than our yield to maturity. What does this mean? This means that we will have a discount bond. What does that mean? It means that we have a bond that sells for less than par value. So this bond's price should be less than $1,000 when we do our calculations. So we're solving for the fair value, that is the price, so that is our present value. The future value is the par value amount of the bond, which is $1,000. The payment is our quarterly coupon amount. So it's 7% of our par value of $1,000. So $70 for the year, however paid quarterly. So I would receive $17.50 every 3 months, so every quarter. My N is the total number of quarters that remain. So I have 4 years remaining on this bond. So 4 years, 4 quarters per year for a total of 16 periods remaining. And my IY is my quarterly interest rate. So 14% is an annual rate. I need to divide that by 4 to put in the quarterly rate, and I get 3.5 as my quarterly discount rate. When I solve for the present value, as we mentioned previously, we do expect a discount bond, a bond selling for less than $1,000, and I do indeed get $788.35 as the current price of this bond based on these conditions. Once again, negative, just showcasing that would be a cash outflow. If I were buying the bond, the price is still a $788.35 bond. So that concludes these review questions. Hopefully you found this video beneficial in valuing bonds and the different features of bonds and solving for fair value or present value and discount rates or yield to maturity. But if I can be of any assistance, please don't hesitate to reach out. Thanks and have a great day.